Okay, here we have a graph of the derivative function y equals f dashed x. So drawn like that, this is the gradient of the function. We've been asked to sketch a curve of what could be the function. We're going to start in the same way with a sign diagram of the first derivative. So we already have the graph of the first derivative, so it's a different process to that which we used in the last example. So zeros, we should always start with zeros on a sign diagram. The zeros are not here and here. They're where the f dashed x has roots on the x's. So that's where f dashed x is 0. The output value is 0. So that happens here, here, and here. So you have zeros. If you think about now the signs either side and in between these zeros, well, here, this side you're below the x-axis, so anything here is negative, so it's negative. Here, between these two zeros, you're above, so it must be positive. Between these two zeros, it's below again. And finally, after the last zero, it's only positive. So that should be enough information to tell you that if this is thinking about the original function, if this has a negative gradient, which looks like that, and then at that point it goes stationary, then it goes positive, well, that's a local minimum. Here, on this side, well, it's positive, and then it's 0, and then it's negative, so that is a local maximum. And here it's negative, 0, positive again. So you can already kind of see that the graph's going to do something like that, which it probably would be enough information to go ahead and draw it. But I'm just going to talk about points of inflection as well. I'm not going to talk about those without a sign diagram for f dashed x. So zeros on f dashed x, when you have a graph of f dashed x, are the stationary points. So that is f dashed x being 0. So the gradient of the first derivative. So bring that down. It's in between these two. And there's another stationary point here as well. Bring it down right there. So there are your zeros, and then you need to look at the gradient of the first derivative. So this side of that 0, it's all positive. Here, and going from this 0 between these two second derivative zeros, negative gradient. And after this one, a positive again, right? So you've got sign changes here and here. So a sign change at this point and at this point. So these are going to be points of inflection. And because at those points the first derivative is not 0, here it's positive, here it's negative, these are non-stationary. So, and then you know you've got local min, and a max, and a min, and either side of those, after this minimum, the function's just going to keep going up, and the same here. It's just going to keep going all the way. So then you should be able to put all that together at the key points and try and draw the thing. So we're going to need an axis. You're going to need you've got these 5 points of interest. So I think I'll put the local points on first. So you've got a minimum about here. That's a minimum, and then you've got a maximum just before the y-axis, and then you've got a minimum just before the end, like that, right? So your function, it needs to start kind of up here somewhere. It needs to go to a minimum there, come up again. Let me try that again. It needs to start from here, go to a minimum, and then it needs to go up to a maximum, and then it needs to come up again, down to a minimum and up again. So something like minimum, then we've got to get up here for a maximum. So up there for a maximum, and then we're going to go somewhere probably around here for a minimum. And then we're just going to go up. Right, so then it might be, I've not drawn it brilliantly, because this really should probably be in between these two, but I'm just going to lay up, so somewhere like that is going to be, let's call that point of non-stationary point of inflection. In fact, if I write points of inflection, I can just draw another arrow, because we have another one around here somewhere. Now it just so happens in this case they kind of fall along the axis, on the x-axis, just because of the way we ended up drawing it. But remember the original function, say it was this, but then plus 6, the whole thing would just be raised up 6, and just think that 6, if we were going back to differentiate it, would disappear anyway. So the fact that this ended up on the x-axis is coincidental, and there's absolutely no need for it to be that. Your graph, it needs to do the right things here and here and here and here and here and at the ends. If it does all of that, the y position is not a factor, it will not gain or lose you any marks.